start with the limits, okay? I'm just going to quickly touch on each of them and then we go on to the next. So as fast as I can. So start with the trig limits. What is it that you must know for trig limits? Well, you must know the basic things. Number one, or first, the two trigs, which is going to be the two things to know is that the limit as theta goes to 0, sorry for that, the limit as theta goes to 0 of sine theta over theta is going to be equal to 1. This one you must know it. Then you must also know the one which, if you go to lecture 3 of limits, at the bottom, you see this one which they also show you to say, the limit as theta goes to 0 of 1 minus cos theta, 1 minus cos theta over theta is equal to 0. So you must know these two. These are two important trig limits that you must know or remember, okay? The limit as theta goes to 0 of sine theta over theta is 1. Then the limit as theta goes to 0 of 1 minus cos theta over theta is 0. Right, we are dealing with trig limits, okay? We're dealing with trig limits, the things you must know. Now, what you must know is, although I write it to say the limit as theta goes to 0 of sine theta over theta, it can be the limit as theta goes to 0 of sine k theta over k theta. This gives you 1 as well. So, in other words, if this is sine of 3 theta, if the bottom is also 3 theta, then the limit will be true. So if you get a sine 3 theta, your job is to make sure that the bottom is also going to be a 3 theta, okay? And how do you do that? You multiply the top and the bottom by the 3 theta to make it 3 theta, okay? And that is going to be the same with anything else. So it's the limit as theta goes to 0 of whatever. You must remember this. And what you must also remember is that the limit as theta goes to 0 of k theta over sine theta, okay? It's like this. This is just going to be equal to the limit. It's still going to give you 1, okay? It's still going to give you 1. If you flip it upside down, this is still going to give you 1 because if you flip it, because this is just going to be the limit as theta goes to 0 of 1 divided by, then you flip it, which will be 1 divided by sine theta over k theta, okay? K theta over sine theta is 1 all over. You flip it back, okay? And this now just becomes the limit of the top, which is the limit as theta goes to 0 of 1 divided by the limit as theta goes to 0 of sine theta over sine k theta, or let's just say sine theta. Let's not make it a k theta. We can just make it a theta. Sine theta over theta. Now this becomes equal to the limit of 1 is 1 divided by this limit here. We know that it's 1, which just gives us an answer of 1. So if we flip it, we still get 1. You may be saying to me, what madness are you showing me right now? The theta over sine theta is 1 over this. 3 over 7 is the same as 1 over 7 over 3. Okay? If you put it below 1, you can flip that fraction. So that's what we did. We put it below 1 and we flipped it back to this form. Okay? So, and then when we are dividing things, you can get the limit of the top and the limit of the bottom, which is what we did in the next stage. Okay? The limit of 1, it will give us 1. Then the limit of the bottom will also give us 1. When we say 1 divided by 1, we get an answer of 1. So this is just what happens. And I'm going to remove the rest. I'm going to remove all these things like that. And that is it. So we have these limits, and I'm sure you have seen it. You should be fine. If you know these limits, then you can be able to solve. Now, let's go ahead and let's solve some problems. But here's the first thing you must know. You must know this. The limit as theta goes to 0 of sine theta over theta is equal to 1. The limit as theta goes to 0 of sine k theta over k theta is equal to 1. Whatever. Make sure you know these, and then you can be able to solve. Maybe I shouldn't solve right now. I'll solve later. Let me just do the data blasting. Blasting you with data. We're doing what we call data blasting. Let's do the other limits. Limits at infinity. So limits at infinity is just going to be the limit as x goes towards infinity. It means x is approaching infinity. It means x is almost infinity. It's at infinity because x is approaching infinity. It's a big number. So x is approaching infinity. So we say the limit at infinity. When you are solving this limit at infinity of anything, what you just do is divide everything, okay, everything, which is everything on the top and everything on the bottom, individually divide them by highest power. Highest power means, the other word for highest power is degree, by highest power in the denominator. Okay, so you can say by x with highest power, by x with highest power in the denominator. So if you the value with your highest or by x or by variable, okay, variable, it can be x, it can be t. The variable with the highest power is the one that's going to divide everything, but the variable with the highest power in the denominator is going to divide everything. Then you're going to start evaluating from there. So remember, limits at infinity, you evaluate them by dividing everything by the highest power in the denominator. Then you're going to evaluate from there. Now, this is for limits at infinity, okay? This is what you must know for the limits at infinity. That is what you should be. That is how we will always solve a limit that goes towards infinity. But you must know that if its limit as x goes towards infinity of a number, say of 7, your answer is just 7. Limit of a number is the number. We don't care what it's approaching. And you must know that infinity is not a number, so we will never put infinity inside our fraction unless it's just at the final solution. We can never say infinity squared or whatever. No, we can't. Okay? So the limit at infinity, this is how you do it. This is how you solve it. Is the limit as x approaches infinity. Remember that. This is the method you do. Okay? Now, we'll see how to evaluate when there is no fraction. This is the method you do when there is a fraction. We'll see how to evaluate just one way there is no fraction. Infinite limits now. An infinite limit is a limit that gives you an answer of infinity. And you should always just check the signs when you're dividing. You know, when you divide anything by a very small number, your answer is going to be infinity. But you should check. If the sign of the top and the bottom are different, then your answer will give you a negative infinity. Okay? If there is negative somewhere at the top or at the bottom, then your answer is going to give you negative infinity. That is it for infinite limits. They solve themselves. You don't have to do much, okay? But we know that you would have reached a limit which cannot be simplified, okay? So infinite limits, these are limits that cannot be, you cannot factorize them, you cannot do anything, and the denominator is approaching 0. So that means the denominator is very small, so it's going to give you an answer of infinity, okay? Infinite limits. Okay, you remember that. That's just common sense. So infinite limits. Okay, one-sided limits now. We should talk about one-sided limits, which is the piecewise. We have for one-sided limits, we are going to have what? Piecewise and the ones that have absolute values. These are the one-sided limits. So we will solve one side at a time, but then the limit as you come from the left should be equal to the limit as you come from the right for that limit to exist. So we are going to solve them individually, but what we know is the individual limits should have the same answer, and then we will have the limit existing, the two-sided limit. So what you have is, let's say you're going to get a limit as x approaches 2 of, let's say, the modulus of x minus 2 or over x minus 2. Now, how do you then solve this one? Well, for you to first solve this one, you need to be able to define this term, okay? Because we will now see as x approaches 2, which one is it going to be? So modulus has a definition. We'll say the modulus of x minus 2, this is going to be equal to, then you put it like this. If the inside is positive, it does not change the sign, so it will remain as x minus 2, okay? That is if x minus 2 is greater than or equal to 0, okay? So that is if it's positive or 0. Then if this inside is less than 0, then it will put a negative outside to change it so that it stays positive, okay? If this is less than 0, that means it's going to be a negative answer. That means the modulus will put another negative outside to change it to be positive, because the job of modulus is to keep the function positive. So this negative outside is to change it back to positive. That is if x minus 2 is less than 0. So this now just becomes, it goes down to say modulus of x minus 2 is going to be equal to, then here it will be x minus 2, and we say if here, what does x minus 2 greater than or equal to 0 mean? You take minus 2 to the other side, you'll be having if x is greater than or equal to 2. And then here it is negative of x minus 2. If here you have x less than, negative 2 goes to the other side, it is x less than 2. So here are the conditions. So if x, now we have a piecewise function and we can do it. So now we will then write this to say the limit as x approaches 2 of the modulus of x minus 2 over x minus 2. What is this going to give us? Well, what are we approaching? We are approaching 2, right? So you can deal with it you do it one side at a time. Remember, that is what you do. So you can say the limit as x approaches 2 from the right. If we're coming from the right, that means we are coming from bigger than 2. So you are going to take here where x is greater than or equal to 2. So that means it will just become x minus 2. So it will be now the limit as x approaches 2 from the right. Now for modulus, you remove it. And what do you put? For x approaching 2 from the right, you put the top one, which is x minus 2. And the bottom is still just x minus 2, okay? So now this is just going to be equal to the limit as x approaches 2 from the right of, since these are the same, they'll cancel and you get 1. Now the limit of a number is the number. We don't care what you're approaching. So this is what it is. Now what if we're getting the limit as x approaches 2 from the left of the modulus of x minus 2 or over x minus 2? Well, for this one, it is going to be, we are coming from the left, so we are less than 2. So here we'll take this one for less than 2. It is minus of x minus 2. So it's minus of x minus 2 or over x minus 2. We're still getting the limit. So it's still the limit as x approaches 2 from the left. Okay, as x approaches 2 from the left of, now what is it? It's going to be negative of x minus 2 over x minus 2. Why is it? Why did you check the negative? Because we're coming from the left, which means we are less than 2. So this is just going to be, what do you then do? You cancel this into 1, into here it's 1. So you have minus 1 over 1 is just minus 1. So it's the limit as x goes towards 2 from the left of minus 1. Limit of a number is the number, so you get minus 1. And you can see that these two limits are not the same. So that means this limit here, which they want, this is called a two-sided limit. The limit as x approaches 2. This one is both from the left and from the right. This one, it just doesn't exist. Okay, why? Because you can just say, since the limit as x approaches 2, you can say since this is since limit as x approaches 2 from the right of x minus 2 over x minus 2 modulus, right, is not equal to the limit as x approaches 2 from the left of modulus x minus 2 over x minus 2. You can say, therefore, now you put limit as x approaches 2 of the modulus of x minus 2 or over x minus 2 does not exist. This is going to be a final solution, and that is how you solve these ones, okay? You see how simple it is? Yes, it is very simple. And now the other limit to know is what? The limit that have piecewise. So for piecewise, we'll always see them. For piecewise, you should just know you first come from the left, then you come from the right, then the two must be equal. So it's just going to be the same as what we've been doing here, okay? This is a piecewise here now, the one which we have here. This is a piecewise. So we changed modulus into piecewise, then we solve. So for piecewise, you'll be having, instead of it saying modulus, it will be just saying f of x is equal to, then it gives you those two things, okay? That's just like what it will be saying, but it's going to still be two parts, and then you test them both and see if they give you the same limit. If they give you the same limit, then it's fine, okay? So I hope you've seen something for the limits, for one-sided limits. The limit from the left should be equal to the limit from the right, and then that is what should happen. Now let's see for the algebraic solution. I'm just going to show you the questions. I won't really solve, and then you can see the videos where I've solved them. But if you go to, which tutorial is it? I think it's tutorial 3 and 4. They have stuff to do with limits. Okay, so here's tutorial 3. This is, we want to now see evaluating some limits that we said are solved algebraically. So which limits have we talked about so far? Trig limits, which are limits that involve trig. Okay, and we've seen what we are going to use. The limit is as theta goes to 0 of sine theta over theta is 0, and the limit as theta goes to 0 of 1 minus cos theta over theta is 0. All right, those two. So after we've seen the trig, after we saw the trig limits, we then saw the limits at infinity, which we know its limit as x approaches infinity. Then we saw the infinite limits, which we said it's limits that give us an answer of infinity. Okay, and so the limits at infinity. So this is going to be what happens. And now we'll be saying the infinite limits are, you can't change anything. You'll be having a limit that is going, your denominator is becoming 0, but there is nothing you can change. You cannot factorize, you cannot do anything, so you'll be stuck. And then in that situation, you will just evaluate. You will be stuck. Remember that. You won't have a way to change that fraction. That is the only time we're going to evaluate it in that form to give an answer of positive infinity or negative infinity. Now we are doing, and then we talked about the piecewise. Limits are not a lot, because in your mind you'll be thinking, oh, they're a lot. No, they are not. Okay, so piecewise, we have piecewise and we have and absolute value, where we said you do one side at a time. Remember, for these ones, you should remember what you do for each of. Remember, for absolute value and for piecewise, you do one side at a time. And remember, for absolute value, for you to be able to do one side at a time, you need to put the absolute value definition. You need to define that modulus. You change it into a piecewise by defining it. And then you can now do from the left, you do from the right. If the two limits are the same, then the limit will exist. Same as for piecewise, you do from the left, then from the right. From the left, it means it's less than that value. From the right, it means it's greater than that value. You'll be choosing the right function to put. Then it's going to be like that. That is for piecewise. Now here we are seeing the limits which we evaluate algebraically, which is the last thing we put in the denominator, where you'll be having a limit where the denominator becomes 0. Okay? If we put -1, we always try to put the value first. If we put -1 here, it'll be -1 plus 1, and it becomes 0. So the denominator here is becoming 0. So that means I cannot substitute. So, but then if I look, there is something I can do here. I can change something. What is that? I can expand this bracket, which is saying squared. So this is the one where we say you expand. But after expanding, you can then factorize it, and then you probably will get an x plus 1 somewhere. Okay? And it will cancel with this x plus 1, and then that is what will happen. Okay? So you first expand it, then you factorize it. So you must know how to expand. You must know how to factorize. If you're not good at factorizing, go check the playlist on factorization, which is at the top there. So, and then there's another one here, which is again the same thing. You expand. But for this one, when you expand, it's just going to have the 25 and 25 cancel, blah, blah, blah. Then you remain with things with h. Then you factor out h, and it's going to cancel with this h, stuff like that. So you can see that for this one, there's something I can change. These are the limits that we say you evaluate algebraically. There'll be something you can change. If you come here, we have a limit here. If we try to put 3 in here, it will come 0, so we can't. But if you see here, we probably can factorize, and we'll get an x minus 3 in here somewhere and something else. And those two, the x minus 3, which you get at the top, will cancel with this one. And that is what you do. So you solve by factorization, which is one of the 4 ways which we've talked about, right? You see it? Then here's another one here now. What do you do here? I see a square root and something outside of the square root. This is the one where you multiply by the conjugate, where you multiply by root 3, by root x, then plus 3. Okay, for conjugate, you just change the sign here outside. So you're going to multiply by root x plus 3. Where on the top and on the bottom, you multiply by root x plus 3. Okay, you'll be multiplying inside the limit. Then it's going to solve itself. You can see the video where I've done it. You can see the solutions on that. But I'm just summarizing for you in your head. I want you to just see all the cases. Here's another one. Again here, you multiply by the conjugate because I'm seeing the square root. So this -1, I'm going to change it to apply. I'll multiply by root of 10x minus 9. Then outside you say plus 1. Same on the top and on the bottom. That's what you multiply by. Then it's going to simplify. Then what about for here? Well, I'll just join in this fraction, and then I will be simplifying step by step because I can't put 0 here. So I'm going to simplify step by step until I get to an answer. But this is another type where you just simplify, so you find a thing to do until something cancels and this h in the denominator goes, and you'll be done. Okay, so these are some limits that you solve algebraically. Here we see that we can combine these two to make one fraction, and then we'll expand it. Then we simplify. When we have two fractions, you can combine denominators, stuff like that. All right, so this is the limits, that is it. Then, and you are done with limits. This is everything to do with limits. You saw the trig ones. Now the idea is to then just know how to solve, do some examples. But that is all you'll be doing, and that is all you need to know on limits, and you'd be done. Okay, so limits, you would be done knowing this and knowing how to solve each one as we have seen. Now the next thing, so here it is done. Section 1 is done. Now the next thing we'll see is intermediate value theorem and squeeze theorem and trig and hyperbolic trig and the continuity and differentiability of things. Then we'll see differentiation and its application. And then you'll be saying, bravo! So you see, 1 is down already. The next is going to be a walk in the park as well. Goodbye for now. See you in the next one.